Let's solve a problem to find the empirical formula of a hydrocarbon. We're given that a 0.450 gram sample of an unknown hydrocarbon was completely combusted, producing 1.320 grams of carbon dioxide and 0.540 grams of water. To solve this, we'll follow two main steps. First, we'll calculate the moles of carbon and hydrogen produced. Then, we'll determine the ratio of carbon to hydrogen. Let's start with carbon. We know that each mole of CO2 contains 1 mole of carbon. The molecular weight of CO2 is 44.01 grams per mole. To find the moles of CO2, we divide its mass by its molecular weight. Therefore, we have 0.030 moles of carbon. Now let's calculate the moles of hydrogen. Each mole of H2O contains 2 moles of hydrogen. The molecular weight of H2O is 18.02 grams per mole. We calculate the moles of H2O by dividing its mass by its molecular weight. Since each mole of H2O contains 2 moles of hydrogen, we multiply this result by 2. Now that we have the moles of both carbon and hydrogen, we can determine their ratio. We have 0.030 moles of carbon and 0.060 moles of hydrogen. To find the simplest whole number ratio, we divide both quantities by the smallest number of moles, which is 0.030. Therefore, the empirical formula of the hydrocarbon is CH2. To summarize, we found the moles of carbon and hydrogen from the combustion products, then determined their simplest whole number ratio to arrive at the empirical formula CH2.